Welcome to Sleepy Scientist Stories. I'm glad you're here. Whether you're curled beneath a blanket listening to the hush outside your window, or letting your thoughts soften somewhere in the quiet of midnight, this space is made for you. Tonight, we'll be gliding gently through one of the universe's more delicate mysteries. A story wrapped in frost, silence, and distant starlight. But before we begin, if these calm explorations help you drift a little more easily into sleep, I'd be grateful if you gave this video a soft like or considered subscribing. It helps more dreamy minds find their way here. And if you feel like sharing, I'd love to know where you're listening from, what time it is there, what the sky looks like outside. Maybe you're tuning in from a tiny village tucked in snow, or maybe you're nestled in a warm city apartment glowing with soft yellow light. Wherever you are, you're part of this quiet journey now. So go ahead, close your eyes if you like, and take a deep, easy breath. Let the outside world fade just a little. You begin in silence, so deep and complete that even time seems to hesitate. Around you there is no wind, no sound, not even the soft hum of atmosphere, just darkness, stretched wide, scattered with distant starlight. Between those stars lies the oldest cold, a quiet so vast it becomes its own kind of presence. Here in this interstellar hush, ice is born, but not the kind you know. Not snowflakes tumbling in beneath a pale sun. No, this is the ice of space where temperature collapses to extremes and water forgets how to crystallize. In these ancient voids, ice forms slowly and without pattern. It gathers not into geometric elegance, but into a formless blur, amorphous, undefined, like a thought still becoming. You drift through this realm, gently, feeling the pause before shape, the breath held before a molecule finds its place. This ice has never felt the warmth of a sunrise. It has never melted into puddles or flowed into streams. It was born in the cold, sculpted by the absence of heat, wrapped around grains of cosmic dust like a soft veil. These are not snowflakes, they are the shadows of water, frozen in place without ever forming a crystal lattice. Scientists call it amorphous ice, a structureless sibling to the intricate hexagons you've seen under microscopes or caught on your tongue in winter. And yet it is everywhere, coating comets, clinging to moons, hiding in the dusk that floats between stars. You let your imagination stretch into that cold, unformed space. You see tiny water molecules lost and drifting, slowed by the deep cold. They settle, quietly, side by side, but without order. They hold hands loosely, with no pattern, like strangers waiting in line for something ancient and unseen. Your breath slows as the idea of time stretches. Out here, molecules may wait thousands of years to find each other. Temperature drops so low it almost stops the dance of atoms. At around minus 150 degrees Celsius, there is too little energy for order. Crystals cannot grow, snowflakes cannot bloom, and yet ice still forms not as a shape, but as a pause, a kind of memory of water, held in a frozen breath. You float now near a distant moon. Perhaps it is Enceladus, Saturn's icy jewel. Plumes erupt from cracks in its surface, spraying vapor into space like quiet geysers. That vapor freezes as it leaves the moon's warm interior, forming snow. Not like Earth's, but flakes without faces, without symmetry, soft-edged and unshaped. Scientists once believed this space now was purely amorphous. No crystals at all, but recent discoveries tell a different tale. Something hidden within this frozen fog seems to remember structure. When researchers at University College London and Cambridge studied this kind of ice, they found something surprising. Using X-rays and simulations, they discovered that some of it, just a small part, had crystallized. Amid the soft disorder, tiny islands of order had formed. Not large, not visible, just nanometers across, smaller than a virus, but real. These crystalline pockets seem to grow inside the chaos, like stars inside clouds. Up to a quarter of this amorphous ice wasn't amorphous at all. It was quietly becoming something more. You feel that transformation now, not sudden, not loud, but steady, as if the molecules, tired of drifting, began to hum together. A soft alignment, a whisper of structure in the middle of a silent void. The beauty of this lies not just in the science, but in the metaphor. Even in places that seem completely unshaped, completely quiet, order can arise. These crystalline fragments are too small to reflect light. You wouldn't see them, even up close, but you might feel them in the way a whisper feels different from silence, in the way a breeze shifts the stillness of a room. You imagine touching this ice. It wouldn't be smooth, it wouldn't sparkle, it would feel like nothing at all. But inside, beneath the story, it would be telling a story. The story of water becoming memory, of molecules trying to arrange themselves in a dance too cold to move. You are made of water. That water, once, may have drifted in just such a form. Before earth, before oceans, before warmth, the hydrogen in your body is older than stars, the oxygen forged in ancient suns. Somewhere long ago these atoms floated in the same quiet frost that coats moons and dust now. You are not separate from this. You carry the memory of these frozen beginnings inside you, and in listening, in imagining, you return to them, not as a scientist, but as a traveller, as a breath in the cosmos, noticing itself. So now, as your body rests and your thoughts drift, let yourself melt into the stillness of this ice. It does not ask to be understood, it only asks to be noticed, in its softness, in its silence, in its refusal to form the way we expect. The next time you see frost on a window, remember that it is just one kind of ice, one voice in a chorus of frozen songs, and that out beyond the planets, beyond the reach of any sun, there are other voices, quieter, stranger, older, formless but no less beautiful. You close your eyes now and drift with them. Because this story is not really about ice. It is about beginnings, about how even in the coldest places something stirs, something gathers, something prepares to become. And in that moment, still and silent, you begin too. The journey has just begun. The darkness is quiet around you, a gentle hush folding over Saturn's domain. One moon, white as breath, drifts into view. Enceladus, not large, not loud, but glowing with secrets. You float toward it slowly, as if your presence might disturb the silence it holds. Beneath its surface, something stirs. There is water here, unimaginable amounts of it, hidden beneath an icy crust like a sea tucked under glass. But Enceladus does not keep its oceans sealed. Instead, it whispers them into space, geysers of water vapour erupting through fractures near its south pole. You watch one of them now. A plume rises, graceful as steam, and what goes up, in the strange gravity of this moon, often falls gently back down. It snows, but not like Earth. This is backward snow, born from vapour, not cloud, falling on a world colder than memory. The snowflakes here do not sparkle with six-pointed elegance. They do not drift from grey skies above green hills. Instead they gather in silence, in shapes that scientists once believed were shapeless. When Enceladus sneezes its ocean skyward, the coal of space catches it instantly. The water freezes mid-flight. But the rules of crystallization that govern Earth do not hold sway here. It's too cold, too fast. The molecules don't have time to arrange themselves neatly. They freeze in place, chaotically amorphous. This snow is not delicate lace. It's more like frosted breath captured mid-air. Still it falls, blanketing the moon's surface again and again, building layers of mystery that no eye can easily see. You drift lower, almost grazing the moon's crust. Beneath your invisible feet, ice stretches smooth and strange. In some places it glows faintly in Saturn's reflected light. In others it glitters with jagged cracks, known as tiger stripes. These are not just scars, they are wounds that breathe them. From them plumes rise with regular rhythm, as though the moon itself inhales and exhales. The material they eject becomes part of Saturn's ring, a thin veil of particles encircling the giant planet, made almost entirely from this tiny moon's offerings. Enceladus is small, but its reach is wide. You pause to wonder how something so cold, so silent, can hold such force. Inside, warmth remains, just enough for water to move, to flow, to break free. Scientists once believed the snow from Enceladus was fully amorphous, frozen without pattern or symmetry. But that was the dogma for years. But slowly a new story emerged. Using simulations and X-ray scattering, researchers noticed tiny hints of structure within that supposed formlessness. Like crystals trying to bloom in a winter too deep, fragments of order revealed themselves. Just a fraction, 20%, sometimes 25%, but enough to change how we see this ice. Crystals too small to touch, too delicate to hold, yet real enough to scatter light in strange and specific ways. You imagine them now, a dance of molecules aligning like dancers who've forgotten most of the choreography, but remember the rhythm. And so, the snow on Enceladus is not entirely without form. It carries a quiet rebellion, a refusal to stay fully disordered. This raises questions that ripple far beyond this icy moon. Could these tiny crystals alter the way heat moves through the surface? Could they shift the moon's reflectivity, changing how it glows in the Saturnian dark? Could their hidden geometry offer shelter for something even smaller? The complex molecules? You don't need answers now. You only need to float, and to feel the gentle gravity of new understanding pulling at the edges of what was once certainty. As you turn slowly in orbit, you imagine snow falling around you. Not flakes, but particles. Frozen breath, a storm of silence. You can't hear it. There is no sound in space. But the image is enough. The moon that snowed backward, offering its over to the sky, then catching it again, like a lullaby in reverse. Each plume is a promise that even in the farthest corners of the solar system, movement happens, cycles continue, ice and vapor, eruption and return. In this rhythm there is something like a heartbeat, something like home, and now you drift upward again, leaving Enceladus beneath you. Its tiger stripes fade into a glowing line. The snow continues to fall. You remember what scientists once thought, that snow in space could not hold structure, that the deep cold erased all patterns. But the moon spoke differently, not in words, but in data, in light and shadow, in particles frozen mid-flight. Enceladus reminds you that assumptions are only temporary truths. The cosmos waits patiently to surprise you. You carry that lesson with you as you rise into the dark, feeling the cold not as discomfort but as stillness, a pause between discoveries. The snowflakes you imagined now trail behind in your memory, leaving questions that sparkle like frost. Where else might such imperfect crystals bloom? What other moons, other worlds hide similar secrets in their frozen breath? And most of all, if ice can organize itself just a little against the odds, what else might quietly take shape in the shadows of space? The thought drifts with you, soft and unresolved, as you glide gently toward the next chapter. Spacecraft exploring icy worlds may one day need to account for this subtle rigidity in their designs. Radiation reflects differently from crystals than from amorphous ice. Heat moves differently. Even the way sound would pass through, if there were sound to hear, is altered. This isn't just a curiosity. It's a map being redrawn, molecule by molecule, crystal by crystal. You rest in this thought for a while, the idea that something so small, so quiet, could matter so deeply. In the vast architecture of space, where stars burn and galaxies collide, it is easy to overlook the tiniest designs. But here in the ice, hidden in cold too deep to feel, a quiet order forms against expectation. You drift on, surrounded by that soft shimmer, letting the questions settle in. If crystals can form where none should be, what else might we be missing in the places we assume are empty? But recently, under the length of X-rays and computer models, a secret began to emerge. Hidden inside the blur of disordered water molecules were tiny pockets of quiet organization. Little crystals, so small they escaped the naked eye, even the keen eye of most instruments, began to flicker into scientific view. Crystals in the very places where none should be. Order, growing gently from chaos. You might imagine a crystal as something sharp, precise, and mathematical. And you're right, but in space this sharpness does not come from heat or pressure. It rises out of stillness, like breath rising in cold air. Researchers recreated the conditions of deep space in their laboratories, temperatures far below freezing, pressures like a vacuum, and watched water freeze again and again. Each time they expected only amorphous patterns, but the data told a different story. Simulations showed that even in these deep cold conditions, a fraction of the ice found its way into crystal form. Sometimes just 20%, sometimes a bit more. Not enough to change the ice's appearance, but enough to change its story. A hidden lattice buried in apparent disorder. Imagine the ice as a woven fabric. Some threads loose, some tight, some dancing alone. Then out of the fog a pattern starts to appear. It's not perfect, it's not finished, but it's real. These tiny crystal structures, sometimes just 3 nanometers across, find a way to embed themselves into the amorphous chaos around them. They grow quietly, gently, as though space itself remembers how to organize, even when no one is watching. The process is not fast, it's not violent, it's not loud. It's a whisper of symmetry, a hum of molecular memory rising from beneath the cosmic frost. And somehow this changes everything, because if crystal ice can form in such conditions, then many of our assumptions shift. How light travels through this ice, how it reflects off the surface of moons, how it traps gases, each of these depends on structure. When scientists search for the ingredients of life in the cosmos, organic molecules trapped in frozen shells, structure matters. Amorphous ice holds space between its molecules, little gaps where chemicals might hide. But crystals leave less room for guests. So the question becomes, how much of the universe's ice is a cradle, and how much is a closed door? The answer might shape how we imagine the first seeds of life arriving on Earth, riding aboard icy grains that once drifted far from our sun. You drift now past Enceladus, Saturn's brilliant moon, where jets of water rise and fall like breath. Scientists believe these plumes carry water vapor from a hidden. As the vapor freezes and falls back down, it was long assumed it did so as amorphous snow. Silent, shapeless, ancient, but what if those flakes shimmer with crystal edges? What if, in their silent descent, they carry not only the signature of motion, but also the fingerprint of symmetry? If so, the surface of Enceladus tells us more than we thought. Its brightness, its reflection, its chemical makeup, all of it changes with the presence of symmetry. What if those faults of Enceladus tells us more than we thought? All of it changes with the presence of symmetry. If Sol, the soul of Meosira, the moon becomes not just a source of water, but a page written in frozen geometry. And now you begin to feel the quiet power of this revelation. A small change in understanding, a subtle shift in ice, ripples outward like starlight. Instruments designed to detect scattered light, spectrometers, telescopes, must adjust for a surface that is not entirely random. Spacecraft exploring icy worlds may one day need to account for this subtle rigidity in their designs. Radiation reflects differently from crystals than from amorphous ice. Heat moves differently. Even the way sound would pass through, if there were sound to hear, is altered. This isn't just a curiosity, it's a map being redrawn, molecule by molecule, crystal by crystal. You rest in this thought for a while, the idea that something so small, so quiet, could matter so deeply. In the vast architecture of space, where stars burn and galaxies collide, it is easy to overlook the tiniest designs. But here in the ice, hidden in cold too deep to feel, a quiet order forms against expectation. You drift on, surrounded by that soft shimmer, letting the question settle in. If crystals can form where none should be, what else might we be missing in the places we assume are empty? But recently, under the length of X-rays and computer models, a secret began to emerge. Hidden inside the blur of disordered water molecules were tiny pockets of quiet organization. Little crystals, so small they escaped the naked eye, even the keen eye of most instruments, began to flicker into scientific view. Crystals in the very places where none should be. Order, growing gently from chaos. You might imagine a crystal as something sharp, precise, and mathematical. And you're right, but in space this sharpness does not come from heat or pressure. It rises out of stillness, like breath rising in cold air. Researchers recreated the conditions of deep space in their laboratories, temperatures far below freezing, pressures like a vacuum, and watched water freeze again and again. Each time they expected only amorphous patterns, but the data told a different story. Simulations showed that even in these deep cold conditions, a fraction of the ice found its way into crystal form. Sometimes just 20%, sometimes a bit more. Not enough to change the ice's appearance, but enough to change its story. A hidden lattice buried in apparent disorder. Imagine the ice as a woven fabric. Some threads loose, some tight, some dancing alone. Then out of the fog a pattern starts to appear. It's not perfect, it's not finished, but it's real. These tiny crystal structures, sometimes just 3 nanometers across, find a way to embed themselves into the amorphous chaos around them. They grow quietly, gently, as though space itself remembers how to organize, even when no one is watching. The process is not fast, it's not violent, it's not loud. It's a whisper of symmetry, a hum of molecular memory rising from beneath the cosmic frost. And somehow this changes everything, because if crystal ice can form in such conditions, then many of our assumptions shift. How light travels through this ice, how it reflects off the surface of moons, how it traps gases, each of these depends on structure. When scientists search for the ingredients of life in the cosmos, organic molecules trapped in frozen shells, structure matters. Amorphous ice holds space between its molecules, little gaps where chemicals might hide. But crystals leave less room for guests. So the question becomes, how much of the universe's ice is a cradle, and how much is a closed door? The answer might shape how we imagine the first seeds of life arriving on Earth, riding aboard icy grains that once drifted far from our sun. You drift now past Enceladus, Saturn's brilliant moon, where jets of water rise and fall like breath. Scientists believe these plumes carry water vapor from a hidden. As the vapor freezes and falls back down, it was long assumed it did so as amorphous snow. Silent, shapeless, ancient, but what if those flakes shimmer with crystal edges? What if, in their silent descent, they carry not only the signature of motion, but also the fingerprint of symmetry? If so, the surface of Enceladus tells us more than we thought. Its brightness, its reflection, its chemical makeup, all of it changes with the presence of symmetry. What if those faults of Enceladus tells us more than we thought? All of it changes with the presence of symmetry. If Sol, the soul of Meosira, the moon becomes not just a source of water, but a page written in frozen geometry. And now you begin to feel the quiet power of this revelation. A small change in understanding, a subtle shift in ice, ripples outward like starlight. Instruments designed to detect scattered light, spectrometers, telescopes, must adjust for a surface that is not entirely random. Spacecraft exploring icy worlds may one day need to account for this subtle rigidity in their designs. Radiation reflects differently from crystals than from amorphous ice. Heat moves differently. Even the way sound would pass through, if there were sound to hear, is altered. This isn't just a curiosity, it's a map being redrawn, molecule by molecule, crystal by crystal. You rest in this thought for a while, the idea that something so small, so quiet, could matter so deeply. In the vast architecture of space, where stars burn and galaxies collide, it is easy to overlook the tiniest designs. But here in the ice, hidden in cold too deep to feel, a quiet order forms against expectation. You drift on, surrounded by that soft shimmer, letting the question settle in. If crystals can form where none should be, what else might we be missing in the places we assume are empty? In the quiet corner of a lab on Earth, a kind of ice was made that no one expected. Not light enough to float, not heavy enough to sink, but perfectly balanced, like an idea not yet chosen. It didn't belong to the types we had known. not the brittle crystalline hexagons of fresh snowflakes, nor the shapeless glassy chill of amorphous ice from space. This new form and medium that seeds liquid water, you let that sink in, or rather not sink, and imagine water frozen so precisely that it hovers in thought, neither rising nor falling. It sounds like a paradox, but the universe is full of quiet contradictions that teach you to pause. In the bitter cold of the cosmos, where familiar laws seem to stretch like taffy, this new ice feels like a whisper from another side of matter. You float through a mental ocean where molecules don't lock into patterns, but also don't tumble into chaos. They hold just enough order to stay together, just enough freedom to drift in stillness. This kind of ice could exist on faraway moons, or within the dense rings of a distant gas giant. It could shape how light bends through plumes, how radiation setters off grains, how time holds its breath in a frozen comet. In your mind's eye you see it now, laid into frost, tucked into the crust of a silent world, reflecting not the shine of starlight but the complexity of balance. Inside this ice there's a strange calm, like the calm between thoughts, or the pause between a heartbeat and the next. No lattice, no jagged edge, just the soft hum of water molecules choosing not to align, but not to scatter either. It's as if the molecules were listening. You drift beside them in imagination, watching the way they cluster without clinging, orbit without touching. If they had a language, it would be one of silence, of closeness, without capture. It's this quiet cohesion that gives medium-dense amorphous ice its rare quality, its sense of existing in between. In a cosmos where everything either rises or sinks, expands or collapses, this ice holds its ground. Back in the lab where it was created, a shockwave of wonder followed. The idea that something could share the exact density of liquid water opened a door into new thinking. What if this form of ice exists in places we haven't yet thought to look? Not deep within stars, nor floating above cold planets, but tucked invisibly between what we expect. You imagine a spacecraft rushing through a cloud of dust, its sensors registering nothing unusual, while hidden inside a grain is this balanced form of water, waiting like a breath caught in the dark. Not a crystal, not a vapor, something softer, quieter, and infinitely more patient. Scientists learnt how to make it by mimicking conditions that might exist in space. Pulses of cold and pressure, applied just so, like the right notes played on a cosmic piano. The result wasn't chaos, but something surprisingly harmonious. This isn't just an experiment, it's a new possibility, one that opens the door to how water might behave in realms untouched by sunlight or Earth's warmth. You start to wonder, could this ice cradle organic molecules? Could it protect life's ingredients inside its delicate density? Perhaps it already does, scattered among comets and dust, sleeping across billions of years, unchanged but not forgotten. This form of ice holds a mirror to your own thoughts. How often do you sit in between, neither certain nor lost, not sinking, not rising, just resting in the middle of a thought not yet spoken? Medium density ice lives there too, in the subtle tension between states. It asks you to consider that some things don't need to choose a side to matter. That balance itself is a kind of wisdom. Maybe, in a way, this kind of ice is more human than you expected. And still, there's more. This balance isn't perfect. It shifts with temperature, reacts with touch, responds to light in delicate ways. It teaches that even the most balanced things are alive with potential, always on the edge of change. You picture a moon holding a crust of this frozen mystery, its core warming slightly, just enough to let the molecules move. One molecule leans toward its neighbour. One pattern begins to form. In the deep silence of space, the smallest dance begins again. You drift back now, not away from the mystery, but deeper into it. Into the thought that ice in its many forms is more than frozen water. It is a memory of temperature, a story of pressure, a geometry of pause. This new form, this floating idea, is not just a discovery, it's an invitation to see stillness as structure, to see the space between definitions as full of quiet meaning. And as you move forward into the next chapter, you carry with you a new way of seeing, that even in ice, Even in silence, there is complexity waiting to be heard. You drift gently into the vacuum, where silence is not the absence of sound, but a space too wide for echo to reach. You watch as vapor slips across dust and clings to its surface, a dance of molecules meeting in the middle of nowhere, freezing not into neat six-sided forms but into chaotic webs, tangled and soft, forming something like a flake but not quite, something not born in wind but in stillness. You imagine this happening across 1 billion places at once, inside the plumes of stars along the icy veins of ancient comets that never fall. Each crystal, though broken, holds a kind of fragile order, like memory trying to take shape. Out here, the flakes do not drift. They cling. They freeze where they are. They build themselves in bursts, molecule by molecule, guided by invisible hands. The vacuum does not allow them the freedom of falling, but it gives them time. Enough quiet for randomness to fold itself into fleeting harmony. You sense that this snow is not delicate in the way you know it, but strong in a new way, able to survive impacts, able to carry stories from one orbit to the next. And the flakes, if they can even be called that, are strange, like abstract sketches drawn by water in its wildest dreams, branching not with symmetry, but with courage. You picture one flake, imperfect and small, drifting through a coma of ice and dust, collecting mass until it becomes a message. A speck that tells of temperatures and pressures you can't feel but can guess. A little archive of conditions written in hydrogen and oxygen. On Earth, snow melts softly, collapses into water, erases itself. But in space the story does not end, it only slows. These icy structures may last millions of years without changing, preserving their jagged patterns until a solar flare or a planetary collision shakes them awake. And so you find yourself wondering, how many of the particles now circling stars, now frozen to a comet's edge, are ancient snowflakes, born of this quiet rebellion? How many have moved from moon to moon, unseen, shaping what follows with the faintest of nudges? You think of all the instruments humankind has ever sent, scanning for light, for shape, for reflection, and you wonder if the beauty they find is only the surface of something far older, more intricate. Each reflection, each scattered photon, may have passed through a snowflake not of Earth, but of the void, and in its path it may have bent just enough to change the story of a planet's birth. There is a kind of elegance in this messiness, a kind of discipline in the freedom of these crystals. They are not wrong, not failed versions of Earth's perfect flakes, but a new expression of what it means to freeze, to take form, to find pattern in absence. You feel this as a rhythm, as if the vacuum hums with the potential of ice, waiting for the next moment of condensation, the next time a vapor plume curls out from a geyser and scatters into the dark, the next time water returns to its waiting partner temperature. You float in this rhythm now, seeing not just snow, but the possibility of it, scattered like seeds across space. A garden with no soil but endless room to bloom. You listen for the soft breath of physics guiding each flake into being, into existence not for beauty's sake alone, but for balance, for memory, for the record it leaves in molecules once too warm to rest. And as you drift, the snow does not fall, but it still arrives, not as flakes in your hand, but as understanding in your mind. You begin to see that every strange fragment is part of a map that traces not geography, but chemistry, not location, but condition. Each one is the frozen signature of where it was born, and what it touched, and what forces shaped its form. In this way, the snowflakes of the void are storyteller, and if you could read their jagged lines, you might know where to find the oceans hidden beneath crusts of distant moons, or where a comet once turned its face toward the sun. These are the quiet guides of space, unreal, unsmelled, untouched, but no less real. And just as you begin to follow their message, something ahead begins to glow, a brightness folded in layers of ice. In the deep stillness of interstellar space, where the cold presses in without motion or end, something impossibly small carries the quiet weight of pattern and order. You imagine a dust grain, so light it doesn't fall, so small it's more idea than object, drifting between stars, wrapped in ice, Not smooth, not jagged, but somewhere in between. Amorphous, they call it. Soft, frozen randomness. But within that randomness, something whispers into shape. A crystal. Not like the gems you've seen in books or on rings, but a lattice so small it vanishes beneath microscopes, just 3 millimeters a meter. And yet it holds a pattern, a rhythm. The molecules press together, not by force, but by the subtle draw of geometry. They find each other like dancers in a fog, forming bonds in the dark, and from that bonding structure emerges. Not by design, just by the silent laws of physics playing out under impossible cold. You float with these particles now, your mind moving as slow as the frozen dust. Around you, the universe is silent, yet full. These seed-like crystals form only under specific conditions, a balance of temperature and pressure, and time so delicate it almost seems like chance. But change with the rules. You picture one of these seeds embedding itself into a larger patch of ice, amorphous at first, but now changed. This seed becomes a center. Around its molecules begin to mimic the pattern, lining up not perfectly, but enough to suggest order. Enough to ripple outward, changing the properties of the ice. And, though you cannot see it, you feel the change. The ice becomes subtly stronger. The way it bends light shifts. Its ability to store heat alters. All from a single crystal, too small to hold, too small to name, yet enough to tip the balance between chaos and order. Even in their tiniest forms, these frozen fragments matter. They guide the growth of planets, affect the chemistry of comets, influence the dust that clumps and spirals and becomes the beginnings of moons. They help shape where life might form and where it might not. Some last 1 million years, some melt in seconds, but all leave echoes. Scientists on Earth try to replicate them, freezing vapor onto cold metal plates, then bombarding the ice with X-rays to see the structure hidden inside. They're learning that even within what looks like fog, patterns bloom. Not everywhere, not always, but enough to say that ice, even at its softest, holds secrets. And one of those secrets is this, that form can emerge from formlessness, that order can grow inside quiet disorder, that something beautiful and precise can form in a place where nothing should. And that brings you to a thought, gentle and wide, that the universe, vast as it is, doesn't always move in grand, obvious steps. Sometimes it changes through moments so small, so quiet, they're nearly missed. A molecule aligns with another, a 3-nanometer crystal forms deep within a snowflake, a patch of shadow gaining just enough shape to become light. Perhaps the next chapter of your journey isn't about what you see, but what you begin to feel in the smallest detail. What happens when these seeds grow? Where do they lead next? The answer may drift just ahead. Quiet, crystalline waiting. You float through a silence so deep it feels like a hum. A space between stars where cold is not just absence but identity, and where water has taken on its most secret form. Around you the ice appears soft and smooth, featureless, like fog held in stillness, but something inside whispers of patterns. This is amorphous ice, scientists once said, unstructured and wild, the kind made not by calm freezing, but by the rapid seizing of molecules into disarray. No crystals, no order, but not all shadows are formless. You drift closer and watch as beams of light, they bounce back in glints and angles, not random, not chaotic. There's rhythm here, a ghost of symmetry. The beams reveal what eyes cannot, nanoscopic arrangements flickering in and out of shape. Somewhere in the structureless blur, hints of repetition hide, delicate and brief. Scientists measure the echoes in diffraction patterns like reading the memory of a ripple long after the stone has sunk. And here they find the impossible. Not perfect crystals, not quite, but lattices, fragments, a hint of design. These are the ghosts of order, embedded in the disorder, like echoes of music in a broken instrument. And they are only a few nanometers across, too small for hands, but not for mathematics. You picture these patterns forming not in some warm laboratory, but in the brutal vacuum of space. You picture them drifting through interstellar clouds wrapped in starlight, shaped by time and the strange memory of atoms. When ice forms quickly, so quickly that molecules have no time to arrange themselves, it becomes amorphous. But even chaos leaves room for whispers. A small fraction of this space ice, 20, maybe 25%, finds a way to align, slipping into partial symmetry as if longing to remember a shape once known. These parts are not visible in a telescope, but they are there, embedded within the irregular like stitches hidden in a fog. Scientists recreate this dance on Earth. In deep cold, they simulate the birth of amorphous ice, then pass it through beams of X-ray and look at the scattering. Each flicker tells a story of density, of arrangement, of structure almost forgotten. One type of amorphous ice, the low-density kind, forms a loose, airy matrix. The high-density version is tighter, more compressed, forged under pressure. But now there's a new player, medium-density amorphous ice, recently created for the first time. It floats in a strange balance, neither sinking nor rising in liquid water. It may be the most familiar ice in the cosmos, yet it's unlike anything you've seen in your glass. And why does this matter? Because ice is not just background, it shapes planets, coats comets, and possibly carries life's earliest seeds. If the ice is more structured than we thought, if it can trap or reflect, align or twist in ways we hadn't predicted, then our models of space and chemistry shift. These subtle lattices could affect how molecules move across surfaces, how radiation is absorbed, and how heat is trapped or released. In the invisible corners of the cosmos, ice becomes a player, not just a stage. And what's more poetic than that? The most ordinary thing, water, becomes a secret architecture in the dark. You float again in silence. The X-rays are gone. The patterns fade. But now you know what lingers beneath the surface of silence. Not nothing, not chaos, but a quiet, intricate human structure. Not nothing, but only in the most unassuming places structure may lie hidden. As if the universe, even at its quietest, cannot help but compose. And so you turn, wondering now about the next layer, about how this hidden order might connect to life itself, and whether the next flake of ice holds more than coldness, it might hold memory. You drift again through the quiet dark where stars blink behind veils of dust and silence, and there, among the debris of 1,000 broken beginnings, you feel it, the promise that life may not begin in warmth but in ice. Not the familiar frost of winter or the sting of cold wind on skin, but something older, something softer. Tiny grains of frozen water drifting between stars, catching whispers of carbon, traces of ammonia, molecules stitched together in stillness. These grains are not empty. They carry with them a delicate code, one that does not shout or burn but waits, quiet and watchful, for a spark, and in this waiting they become more than dust. They become potential. You imagine these ancient grains journeying through the interstellar dark, bumped and battered by shock waves from dying stars, nudged by gravity from newly forming worlds. Their path is long and unwitnessed. Yet all the while, something within them changes. A subtle rearrangement of atoms sparked by ultraviolet light, or the slow chemistry of cosmic time. On Earth we think of life as needing warmth, water and movement. But here, in this deep freeze, perhaps the first seeds were sown not by heat, but by stillness. By the silence of a billion-year winter in which molecules found one another by chance, locked hands and held on. These icy grains, laced with hints of methanol, formaldehyde and simple sugars, may be far more than life's list dust. In laboratory experiments, scientists have recreated these grains and bombarded them with light, like that of distant stars. What they find is striking. Amino acids, the raw ingredients of life, begin to emerge. Not in abundance, not in clarity, but just enough to suggest a blueprint, a ghost of biology written in the frost. And you realize that these grains may be the oldest couriers of life, not carriers of organisms, but carriers of possibility, delivering the parts, the whispers, the unassembled puzzle pieces of something that might become living when the time is right. But then a question forms in the dark. What if ice, for all its grace, was too fragile a cradle? The structure of amorphous ice is chaotic, full of gaps and tangled paths. It can protect, yes, but it can also trap. But the very molecules that might give rise to life could find themselves locked away too tightly, unable to meet, unable to speak. In some forms of cosmic ice, the crystalline structure is more rigid than we imagined, leaving less room for interaction. The hope that life's building blocks floated freely may now share space with the possibility that they remain sealed, beautiful but inert. Still, the universe is persistent. You float through the remains of an ancient comet, its surface scarred by sunlight, its heart still wrapped in mystery. Here the ice is different, processed by time and heat, cracked open by radiation, and in these cracks, life's ingredients might dance. Perhaps not life itself, not yet, but the shadows of it, moving just enough to spark what's next. Some researchers believe that comets, icy and chaotic, may have carried these ingredients to Earth, seeding the oceans with raw material for the chemistry of life. Others remain cautious. The data is incomplete, but your mind stretches with wonder. It's not the certainty that matters now, it's the possibility. You remember that space is not sterile, not empty. It is filled with noise, electromagnetic, gravitational, thermal. Even in the coldest corners, particles collide. You imagine a tiny dust grain caught in a cloud of a forming star, its icy coat melting, mixing, reacting. For the first time in eons, something flows, something meets, a drop of liquid, a flicker of heat, and in that moment all the frozen chemistry from light years of drifting may come alive, not with breath, not with heartbeat, but with the simple click of molecules joining hands. You are watching not birth, but prelude, the slow unfolding of something ancient and new. And as you drift farther, you begin to feel the weight of this quiet story. Life as you know it may be rare. It may require exquisite timing, delicate temperatures, and lucky collision, but the ingredients are not rare. They are everywhere, tucked into ice, curled into dust, waiting. Not every grain will become a spark. Most will vanish unnoticed. But some, perhaps just a few, will find their way to warmth, to water, to rhythm. And there, what began in silence might one day speak, might one day open eyes, might one day wonder how it began. You float in that thought now, suspended between certainty and hope, wondering what comes next, wondering what waits in the chapter ahead, where molecules move and memory begins to form, because this journey is not only about ice, it's about the thin line between cold stillness and something that stirs, something that calls itself alive. You drift further now, past the places we've seen and named, into the realms we only imagine, where ice does more than freeze, where it waits with purpose. Out there on moons with hidden oceans and comets curled in deep time sleep, frozen water holds more than memory. It holds promise. In this stillness lies potential not just for science, but for something tender. You think of Europa, Enceladus, and Pluto's icy heart, not lifeless, but unread. These worlds whisper not in words, but in temperatures, in crystalline formations that have yet to meet a sunrise. We send machines to touch them, to scratch their frost and gather the breathless silence they carry. With each mission, a question deepens. What if ice isn't the end of a process, but the beginning? Now your mind follows the trail of vapour that burst from a geyser on Enceladus, racing through sap. This ice, flung high into the void, might one day rest on another world. It might be gathered, studied, or even melted into water for human hands. You imagine astronauts collecting it, using ancient coal to make fire, drink, to stay. Perhaps the first humans on Mars will walk not on red dust alone, but on frost that once travelled between stars. Perhaps future explorers will harvest ice, not just for survival, but to understand the biology locked inside. Molecules once carried across galaxies. The past moves forward in frozen forms. You wonder if we've met our own origins this way, once upon a comet's trail. Even in our own backyard, frozen places speak of what's possible. Antarctica holds bacteria that sleep through centuries. Arctic glaciers trap pollen from long-gone trees. We find viruses older than our cities, still patient in permafrost. Ice keeps time differently. It does not age. It remembers. And in this remembering, it offers a gift. When we look for life beyond Earth, we don't just look for oceans. We look for places where ice may be breaking, where warmth may be trying. We follow fractures and tides in frozen crusts, hoping for signs of chemistry that never gave up. You close your eyes and imagine it again. Life not blooming in sunlight, but quietly humming in darkness, beneath layers of cold glass that never cracked. And so you float here at the end of your journey, not with an answer, but with a question folded softly in your hands. Ice, once thought simple and passive, has become a symbol of something more. In every crystal, a mystery of physics. In every pattern, a memory of motion. And in every stillness, the echo of possibility. The future may not burn bright, it may form slowly, molecule by molecule, in the heart of frozen silence. And perhaps that is enough. Perhaps that is how we will begin again, with one flake, one shape, one waiting world, gently unfolding.